Yes, today we will discuss about moment of inertia. But as here, moment inertia, as you know, this is the rotational tendency of a the inertia means this is the ability of a body to resist the change. This is the ability of the body to resist the change in state of its motion. It means that a particular body is not want to change its states of motion, and more the mass of the body, that body will not easily tends to change its states of its motion. For changing the motion of that body, large amount of force is required. Large amount of force is required. Now, moment means rotational moment of force means a torque. So that's why when the body rotates, the inertia related to this is called rotational inertia or moment of inertia. Now you see here, but all of you see, so moment of inertia is the product of moment of inertia. Moment of inertia is the product of is the product of mass of the body, mass of the body, perpendicular distance, and square of perpendicular distance. Distance from axis of rotation, from the axis of rotation. So see here, all of you,
सर क्लियर दिखाई नहीं दे रहा है क्या लिखा हुआ है मोमेंट ऑफ इनर्शिया इज
moment of inertia is the product of mass of the body and perpendicular distance from the axis of rotation, and the perpendicular distance from axis of rotation. It means this is the axis. Now over this axis, if we clamp a rod, and with the rod we attach a mass m. The distance, beta, when we hit this mass, it will rotate around the axis like this. It means this body, this mass will move in a circular path. But this mass starts to rotate around this axis. This is the axis of rotation. Axis of rotation. And this is the perpendicular distance r, and this is the mass of the body. This mass m, this mass m is rotating around this axis. And what is this perpendicular distance? R. So moment of inertia of this body, this is the product of mass of the body and square of the perpendicular distance. So you should know why I have written this formula. I is equals to mr square. So you should know here that what is the formula of moment of inertia of any mass rotating around any given axis. Its formula is m into square of the perpendicular distance. So let us derive this formula. So you should know that moment term is there. So moment of force means torque. So first you should know what is moment of, but you should know what is moment of force. Moment of force means torque. Moment of force means torque. See here, beta. If this is the axis of rotation, this is a rigid framework, and you are applying force in this direction. Force. What is the perpendicular distance? R. बेटा जैसे कि आपने देखा होगा जब ट्रक का बेटा व्हील पंचर हो जाता है उसके तो उसे क्या करता है, उसके नट को खोलने के लिए एक बड़े से रॉड को यूज करता है। किसका यूज करता है? बड़े से रॉड को यूज करता है, और वो रॉड को क्या करता है, नट में लगा देता है, और उस एक सॉकेट इसे कहते हैं, इसमें होल होता है, उस होल में रॉड डाल देता है। बेटा ये रॉड डालने के बाद दूर पर फोर्स लगाता है, तो ये सॉकेट, ये नॉट आसानी से खुलता है। बेटा अगर ये रॉड छोटा होगा
सर एक बार फिर से समझा दो।
बेटा देखो, जब ट्रक में जो नोट्स लगा होता है बड़े बड़े और वेरी हैवी होता है, उसे खोलना होता है, तो क्या करते हैं, डायरेक्ट हाथ से तो खोल नहीं सकते। शुभम गुप्ता तो हाथ से खोलेगा नहीं, शुभम गुप्ता खोल सकता है, इसके अलावा कोई और नहीं खोल सकता। हाँ देखो इधर, बाकी और कोई बच्चा नहीं खोल पाएगा। लिसन हियर, इसके अंदर सॉकेट डालते हैं बेटा, और सॉकेट देयर इज अ होल, वी अप्लाई फोर्स हियर। बेटा रोड अगर लंबा होगा तो खोलना आसान होगा, रोड अगर छोटा होगा तो खोलना मुश्किल होगा। परपेंडिकुलर डिस्टेंस, तो फोर्स यहां। अब व्हाट इज टॉर्क? मोमेंट ऑफ फोर्स, दैट इज टॉर्क। बेटा torque is force into perpendicular distance. This is the cross product. What is torque? Torque is the cross product of force. Torque is the product of force and perpendicular distance from axis of rotation. Perpendicular distance from axis of rotation. बेटा आप देखिए, ये परपेंडिकुलर डिस्टेंस, या फोर्स को ही परपेंडिकुलर ले लेते हैं। फोर्स का परपेंडिकुलर कंपोनेंट इज एफ साइन थीटा, दिस इज इक्वल टू दिस एफ साइन थीटा। सो टॉर्क कैन बी रिटन एज tau is equals to what is the perpendicular r, and what is this perpendicular component of force? F sin theta. This is F sin theta. The perpendicular component of force is F sin theta. So torque is what? Torque is a force which produces rotation in a body. Torque is a force which produces rotation in a body. Now, magnitude of torque is product of force and perpendicular distance, or either you take perpendicular component of force or distance from axis of rotation. So see here, you know force is equals to mass into acceleration, into sin theta. Now you see here, what is acceleration? That is, acceleration is equals to dv by dt, rate of change of velocity with respect to time. Now you know sin theta, you know v is equals to omega r. V is equals to omega r m, omega r into sin theta by t. Now this is equals to torque. You know torque, so m r square and omega upon t is alpha. Omega upon t, rate of change of angular velocity with respect to time. Beta, this is alpha. M r square m r square into alpha into sin theta. That is torque. देखो बेटा, all of you, everybody see, rate of change of angular velocity. We can write A is equals to dv by dt and V is equals to omega r. So we can write here d omega upon dt, d omega upon dt. So rate of change of angular velocity with respect to time, that is angular acceleration alpha, mr square. देखो बेटा, torque is equals to force is equal to mass into acceleration होता है. Beta, this term torque, when we provide rotation to any body, when we want to twist when we want to unscrew this knot of a wheel, then we provide what? Torque. So torque is equals to I into alpha. Beta, torque is a force which produces rotationary motion and force produces translatory motion. टॉर्क इज नोन एज द मोमेंट ऑफ फोर्स. बेटा टॉर्क क्या करता है? किसी बॉडी को घुमाता है. तो बेटा ये जो एम आर स्क्वायर टर्म आया, दिस इज नोन एज टॉर्क इज इक्वल्स टू आई अल्फा होता है. टॉर्क इज इक्वल्स टू आई अल्फा. टॉर्क इज इक्वल्स टू आई अल्फा एंड साइन थीटा. टॉर्क इज इक्वल्स टू आई इनटू अल्फा. एवरीबॉडी नोट डाउन, टॉर्क इज इक्वल्स टू आई अल्फा. Torque is equals to I alpha. And what is I? Moment of inertia. I is known as moment of inertia. And this is the product of mass of the body and square of the perpendicular distance. I is mr square. Alpha is angular acceleration, rate of change of angular velocity with respect to time. M r into r square. mr square is the moment of inertia. Alpha is angular acceleration. So here, just like force is equal to mass into acceleration, so the rotational analog of force is torque. Torque is equals to moment of inertia into angular acceleration. In a body, it provides angular acceleration. So it will increase the or decrease the velocity of a body, angular velocity of the body. Alpha is angular acceleration, that is d omega upon dt. I is equals to mr. What is the formula of I? mr square. Yes, but all of you click this one. Torque is equals to I alpha. Now see here, all of you. Before going further, let us solve some problem that is related with the torque. Let us see here. If this is any body and this is the axis of rotation, this is the axis of rotation one force is acting here in this direction, F1. This is 20 Newton. And what is this distance? 2 meter. One force is acting at this point. What is this distance? 90 degree, 90 degree. F2. No, this is not 90 degree. This force will be like this. F2. This is 30 Newton. And distance is 2.5 meter. Let distance 2.5 meter. Now, what is the torque? Find torque acting on the body. Find torque. You see here, you know torque is equals to force into perpendicular distance. Force into perpendicular distance from axis of rotation. Now you see it. Here two forces are acting. Now you see here, but this force will rotate this body in anti-clockwise direction, and this force will rotate the body in clockwise. How you can say? This is the center point. From here, R position vector you always consider torque is equals to R cross F. Now you see here, R cross F. R is this distance. बेटा व्हाट इज दिस एंगल? R से F की ओर जब जाएंगे एंटी क्लॉक, तो बेटा ये इस बॉडी को एंटी क्लॉकवाइज घुमाएगा. बेटा ये R1, this is F1, this is R2, this is F2. What is the direction of R2? Along this. R2 से R से F जाना, R2 से F2 की ओर जाएंगे. बेटा ये क्लॉकवाइज जा रहा है, यानी कि this force produces clockwise rotation and this force produces anti-clockwise rotation. So here how we can take the perpendicular distance F or perpendicular component of force. See here beta, this one, this is parallel component of force, this is perpendicular component of force. This F2 sin 30. F2, this angle is, let this angle is 30 degree. This angle is 30 degree. F2 sin 30 degree, perpendicular component of this force. Now you see here, बेटा ये फोर्स लगा और दिस फोर्स इज ऑलरेडी परपेंडिकुलर, now you see here, net torque will be the sum of torque produced by force plus torque produced by second force. Now you see here, we already take, there is a sign convention beta, for anti-clockwise rotation torque is positive, for clockwise rotation torque 1 is negative. So torque due to first force will be positive. And what is this torque? But this is the axis of rotation. This is any rigid body. On this rigid body, two forces are acting, F1 and F2. Now you have to determine the net torque due to this force. You know that torque is equals to force into perpendicular distance. Since this force is already perpendicular, so torque and this rotation are subtend further. R, you have to move R cross F. So rotation is from R to F is anti-clockwise. So torque due to first force will be positive. Now you see here, all of you. What is this force? F1. What is this perpendicular distance? R1. What is this angle? Sin 90. Sin 90.
सर
Yes.
सर आपका नेटवर्क थोड़ा एरर आ रहा है,
Wait.
सही से सुनाई भी नहीं दे रहा.
रिकॉर्डिंग बंद कर दो सर.
Wait, all of you see. Now, torque due to this force will be negative. Why? You know that torque is equals to R cross F. So, beta, we have to move from R vector से F vector की ओर हमें जाना है R towards F. What is this angle? 30, and we are moving in clockwise direction. So, F2 R2, and what is this angle? Sin 30 degree. Sin 30 degree. Here plus sign. Why? Because the rotation is anti-clockwise. Here minus sign because rotation is clockwise. Now you see here, all of you. If what is the value of F1? 20 Newton. What is of this perpendicular distance? 2. Sin 90 क्या होता है बेटा? 1. तो ये हो गया 40. बेटा ये माइनस हुआ. माइनस क्यों हो गया? बिकॉज F इधर लग रहा है, F2 इधर, और R का डायरेक्शन इधर है. यहां से R से F की ओर कैसे जाएंगे? क्लॉकवाइज. एंड क्लॉकवाइज मींस नेगेटिव. माइनस. व्हाट इज द वैल्यू ऑफ F2? बेटा 30 न्यूटन. डिस्टेंस परपेंडिकुलर डिस्टेंस 2.5 और sin 30 क्या होता है बेटा? 1/2. 1/2. तो ये आंसर आपका आ जाएगा माइनस, दिस इज व्हाट, इसे कट करो, इट विल बी 2.5. What is the unit of torque? Meter, Newton, Newton meter, Newton meter. So 2.5 Newton meter is the torque acting on the body. 2.5 Newton meter. What is the torque acting on the body? That is 2.5 Newton meter.
मतलब सर इसमें हम लोग फॉर्मूला टॉर्क इज इक्वल टू ये फोर्स इनटू परपेंडिकुलर डिस्टेंस यूज करेंगे फॉर्मूला
From axis of rotation. Now you see here once again you see everybody. This is any framework. This is heart shaped any body is there. And this is the point. This is the axis passing through this point. So what is the perpendicular distance of axis from this force? From this force F1, this the perpendicular distance is 2 meter. This angle is 90 degree already. Now, you don't take it, take R and F. What is this angle? 90. RF sin 90. This is R and F. What is this angle? 30 degree. Clockwise rotation means minus, anti-clockwise rotation means plus. So this is one is 40 and this one is 37.5. So 40 minus 37.5, your net torque acting on this body is 2.5 Newton meter. 2.5 Newton
सर
meter.
फोर्स इनटू परपेंडिकुलर डिस्टेंस इनटू sin थीटा भी आएगा sin थीटा
Yes, the perpendicular distance. तो that perpendicular distance कैसे निकाला? और perpendicular component of force. देखो बेटा, ये R और F का sin थीटा component F2 इसलिए लगा sin लगा sin 30. Why? R2 and F2 both are perpendicular. We are not taking a cos because F cos 30 will be the parallel to this R2. We have to take perpendicular to this vector. Perpendicular to the R2 is F2 sin 30. That's why F2 sin 30 into R2. F2 sin 30 into, we have to take perpendicular component of force into distance. Perpendicular component of force into distance. Here also, perpendicular force into distance. Getting? Perpendicular component of force into distance from axis of rotation. Now you see here, all of you, as we are discussing about moment of inertia. And what is the formula of moment of inertia? This is mr square. Mr square. Beta, if you are asked to
यार ऊपर से दिख नहीं रहा
yes beta
थोड़ा नीचे लिख लो
बेटा ये क्या हो गया this is what this is axis of rotation यहाँ दो body है this is first body whose mass is m1 this is second body whose mass is m2 perpendicular is r. Now what is the total moment of inertia? Determine the moment of inertia. So moment of inertia here two bodies are there. So inertia moment of inertia first body is I1. Moment of inertia second body is I2. Moment of inertia is scalar quantity होते बेटा. Torque is a vector quantity. But moment of inertia is scalar quantity. So चाहे ये distance हो चाहे ये distance हो both positive ही होगा negative नहीं होगा scalar quantity. So what is this m1? What is perpendicular distance? r1 mr square. But a बहुत simple formula है mass into square of perpendicular distance. That is moment of inertia. This is what axis of rotation. For second body, what is the mass? m2. And what is the perpendicular distance? r2. r2 का square. So total moment of inertia will be this. Total moment of inertia will be inertia of these two bodies about the given axis will be the sum of moment of inertia of the first body plus moment of inertia of the second body. Now all of you see, if you are asked to determine the moment of inertia of a continuous of a body whose mass is continuously distributed. So moment of inertia of continuous distribution of mass, continuous distribution of mass. First example, moment of inertia of a ring of mass m and radius r r. What is the radius of the ring r and what is the mass m? The mass of the ring is m and its radius is r.
सर लैपटॉप पर